let me just maximize the window. Great. Hi, everyone. Today I want to talk about the gas limit and how we can get a better understanding of it. So this question comes up all the time. Should we raise the gas limit? Lots of people have strong opinions on this, but the truth is nobody really knows the answer. And this is because nobody has detailed quantitative evidence on what the optimal gas limit is. So Ethereum is a complex system. And downstream of the gas limit, there are hundreds of different parameters and bottlenecks and metrics that need to be considered. So to tweak the gas limit, we need detailed quantitative evidence to justify what we're doing, rather than relying just on intuition. But this is a really hard problem. So over the past year, I've been trying to understand the gas limit in a more data-driven way. And the most interesting thing has been learning what the true bottlenecks of Ethereum actually are. So for example, there's a common belief or common view that the main problem with raising the gas limit is state growth. The state grows too big. And this is somewhat true, but it turns out that other bottlenecks are more significant, like history growth and bandwidth. So this is a graph showing that history growth is a much larger storage burden for node operators compared to state growth. So I think that the only way for us to gain clarity on scaling Ethereum is doing this type of data-driven analysis sort of times 100 and leaving no stone unturned. So how can we use data to supercharge gas limit research? I want to describe a general approach that can help us answer 3 of the most important questions related to the gas limit. So the first problem is, how do we price long-term storage? Storage is a lot different than other hardware resources like CPU or bandwidth, because storage creates a long-term commitment, a long-term burden, whereas other resources are used instantaneously. And right now, I think storage is mispriced, especially on L2s, and we don't really know the true cost that storage imposes on the network. A way to approach this problem is we come up with a new pricing scheme for storage, such as multi-dimensional gas, or state expiry, or some ZK thing. And then we do a data-driven comparison between the new scheme and the current scheme. And this can be extremely detailed. We can look at every single transaction and block and protocol in Ethereum's history, and we can rigorously examine all the downstream effects of this new pricing scheme. Another gas limit problem is, how do we make the worst case closer to the average case so that we can do more in each block without risking a denial of service attack? And so EIP 7623 is a great example of this. It brings the worst case block size down closer to the average case block size. And you might ask yourself, if we can do this for block size, can we do it for a bunch of other block metrics, like the number of times that a certain opcode gets used? A simple solution is, let's just impose new rules on block building. We can evaluate this solution sort of using the same approach that I just described, where we look at the entire history of Ethereum blocks. We can pull in old snapshots of the mempool, and we can evaluate a detailed breakdown of how these new constraints might affect all the different things that we care about. And then the final boss of the gas limit problems is, what is the optimal gas limit? And how do we safely balance network health with network performance? And again, this is a hard problem because Ethereum is a complex system with hundreds of different parameters and bottlenecks and metrics. But it's not an impossible problem. We can model all of these different bottlenecks and metrics as a function of the gas limit and use data to inform those models. And I think ultimately, this is the endgame approach for understanding the gas limit and guiding our decision on what it should be. If you want to learn more about how to actually dig into the crypto data, come to my other longer talk in an hour on stage 3, and thanks for listening.
Thank you so much. Are there any questions from the audience? And maybe people are still typing, but I'm interested in what was the motivation behind deep diving into this topic more? It's like, what inspired you?
Yeah, so right now, Ethereum, it's sort of notorious for being more expensive than other blockchains, and this is due to the gas limit sort of clamping down on the amount of transactions per second that Ethereum can handle. And there are really good reasons for doing this. If you allow too many transactions, that can compromise network health, decentralization, other things we care about. But at the same time, we want to make sure that we're in the right sort of sweet spot in that trade-off space.
Okay, thank you. There's already one question. What kind of tools you use to collect the data? Are they mature or we need better tools?
At this point, the tools they're getting really good. And I actually go into detail, like I said, in this other talk in an hour, if you can make it. But the short answer is I use Cryo, which is a tool I built to extract a bunch of blockchain datasets, and then I use polars to analyze that data and slice it up in a bunch of different ways. And it's really efficient and really robust.
Okay, thank you. The questions are popping in now. Which bottleneck do you see as lower-hanging fruit to fix?
So probably history growth is the most obvious example there. History takes up a huge amount of space on every full node. And we actually have a solution for this that people have been working on for a long time called EIP 4444, where instead of every node keeping a copy of the entire history, we move sort of toward a different distribution scheme, and then all of the nodes will have a lot more runway for either the state to grow big or just make it less burdensome to run a node.
Thank you so much, Storm. I think time is up. Those who have additional questions, as he said, there will be a long format of his talk. Maybe you can follow there and then place your questions there. Otherwise, he's there for answer questions after this session. Thank you so much, Storm.
Thanks.
Thank you.